Hello everyone, myself Purva Joshi, Assistant Professor at LJ Institute of Engineering and Technology. Today we are going to discuss few more topics of sequence and series. So let's begin with the first topic, that is absolute and conditional convergence. So the series UN is called absolutely convergent if the series mod UN is convergent. Okay, so whenever we have a mod UN is convergent, then we can say that this series UN is absolutely convergent. Okay, next, if the series UN is called conditionally convergent if the series UN is convergent but the series mod UN is divergent. Okay, so whenever we have this type of condition, that is series UN is convergent but the series mod UN is divergent, then we can say that this series UN is conditionally convergent. Okay, next, if the series UN is absolutely convergent series, then series UN is convergent. Okay, and if convergent series is a positive term series, then it is absolutely convergent. So whenever we have a positive term series which is a convergent, then we can say that it is absolutely convergent. Okay, now let's study one example. Determine absolute or conditional convergence of the series minus 1 raised to n into n square upon n cube plus 1. Okay, so here un is given, that is minus 1 raised to n into n square upon n cube plus 1. Firstly, we will write down mod un. Okay, so mod un, so means here we have to take only positive terms, right? So we will write just this n square upon n cube plus 1. Now we will check whether this series mod un is convergent or not. So for that we will apply limit comparison test. Okay, so firstly take out this n cube common from the denominator. So you will get here n cube into 1 plus 1 upon n cube, right? This n square will get cancelled. So what will remain is 1 upon n into 1 plus 1 upon n cube. Okay, now we will suppose Vn as what? 1 upon n, right? So Vn is 1 upon n. For next, we will find limit n tends to infinite mod un upon Vn. Okay, so un upon Vn. So this 1 upon n will get cancelled. What remains is limit n tends to infinite 1 upon 1 plus 1 upon n cube. And we know that this limit n tends to infinite 1 upon n is equal to 0. Right, so this term is 0. So what remains is 1. So it is a finite and non-zero term, right? And we will see the series Vn, that is series 1 upon n is a p series test with p equals to 1. Okay, so we can say that the series Vn is divergent by p series test. Okay, and therefore we can say that the series mod un is also divergent by limit comparison test. Okay, so the given series is not absolutely convergent. Okay, so we will check whether it is conditional convergent or not. So for that, we will take mod un minus un plus 1. Okay, so here we will apply this Leibniz test for the alternating series, right? So mod un minus mod un plus 1. Mod un is given, that is n square upon n cube plus 1. Okay, write down mod un plus 1 means in place of n, we have to write n plus 1. So you will get n plus 1 whole square upon n plus 1 whole cube plus 1. Okay, now further simplify this. So apply the formula and further simplify. So here you have to cross multiply and simplify. So you will get mod un minus mod un plus 1 is equals to n raised to 4 plus 2n plus 1 into n square minus 1 upon n cube plus 3n square plus 3n plus 2 into n cube plus 1. Okay, so from this you can see that it is greater than 0, right? Therefore here we have mod un greater than mod un plus 1. So this is the first condition of Leibniz test, okay, which we have satisfied. Now the second condition, that is limit n tends to infinite mod un equals to limit n tends to infinite mod un, just substitute. Okay, now again we have to take n cube common from the denominator, n square will get cancelled. What remains is this and we know this limit n tends to infinite, 1 upon n is equal to 0. Okay, so here we have answer 0. So this is the second condition of Leibniz test. Okay, so by Leibniz test we can say that the given series un is convergent, right? Therefore we can say that the series un is convergent, but the series mod un is divergent. Therefore the given series un is conditionally convergent. Okay, now let's see one more example. Determine whether the series cos n upon n square is equal to. Okay, just expand it. Firstly, substitute n is equal to 1. So you will get cos 1 upon 1 square plus next is cos 2 upon 2 square and so on. Is convergent or divergent? Okay, so let's begin with the solution. Here un is given, that is cos n upon n square. Okay, so firstly we will write mod un, that is mod cos n upon n square. Now we know this mod cos n is less or equal to 1. Okay, so divide it by n square. So you will get this condition, right? Now we have this form, that is mod un less or equal to vn. Just suppose this 1 upon n square as vn. Okay, so you will get this condition. Now the series vn, that is series 1 upon n square. This is a p series test with p is equal to 2. Therefore we can say that the series vn is convergent by p series test. Okay, and therefore we can say that the series mod un is also convergent by direct comparison test. Why? Because here we have this condition and also this vn is convergent. Therefore by direct comparison test we can say that this series mod un is also convergent. Okay, so we can say that the given series un is absolutely convergent. Next topic is power series. A series of the form summation an x minus a whole raised to n is equal to, expanded, first n is equal to 0. So you will get a0 plus a1 into x minus a plus a2 into x minus a whole square and so on. Okay, this is called a power series in powers of x minus a, or a power series about a point x is equal to a. Here x is a variable and ans, that is a0, a1, a2, these are constant and it is called the coefficient of the series. Okay, let's see one example. Suppose we have the series n from 0 to infinite x raised to n upon n factorial, which we can write as 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial and so on. So this is a power series in powers of x. Okay, now let's begin with the example. So test the convergence of the series 1 upon 1 into 2 into 3 plus x upon 4 into 5 into 6 plus x square upon 7 into 8 into 9 plus 1 where x is greater than 0. Okay, so whenever we are solving any example of the power series, we will either solve it by the ratio test or root test given according to the condition of un. Okay, so let's begin with the solution. Here un is given, that is x raised to n minus 1 upon 3n minus 2, 3n minus 1, 3n. So this we have to find, right, from here. Now from the numerator you can see that we have x raised to 0, then x raised to 1, then x square. Okay, so here x is fixed but this 0, 1, 2 is changing. So we have 0, 1, 2 and so on. So we'll apply this formula to find the nth term, that is Tn is equal to a plus n minus 1 into d. Okay, so a means first term, so first term is 0 plus n minus 1, difference is 1, so you will get n minus 1. So here we have x raised to n minus 1, right? Next, consider this, that is 1, 4 and 7. Okay, so from 1, 4, 7. Again we have to apply the same formula, a plus n minus 1 into d. A is 1 plus n minus 1, difference is 3. Okay, simplify. So here you will get 3n minus 3 plus 1, right? On simplification you will get 3n minus 2. Similarly, if you solve for 2, 5, 8, so you will get 3n minus 1, and for 3, 6, 9 and so on you will get 3. So in this way we can find the nth term. Okay, now we will find un plus 1, that is x raised to n upon, in place of n just write down n plus 1, so you will get x raised to n upon 3n plus 1, 3n plus 2 and 3n plus 3. Here we will apply ratio test. Okay, so firstly find out this un plus 1 upon un. Okay, so this answer of un plus 1 and this un, just here we have to reverse it. Okay, now this x raised to n will get cancelled. Okay, so here we have x raised to minus 1 which will come in numerator. So here we have x. Take n common from this, so this will give you n cube which will get cancelled with the denominator from this 3n, and what remains is only this term. Okay, next we will apply limit, that is limit n tends to infinite un plus 1 upon un. So this is equal to limit n tends to infinite. Now we know this limit n tends to infinite 1 upon n is 0. So this all the terms will go to 0. So what remains is only x, because here we have 3 into 3 into 3 and here in denominator we have 3 into 3 into 3. So it will get cancelled. So what remains finally is x. So by ratio test we can say that the given series is convergent if x is less than 1. It is divergent if x is greater than 1, and test fails for x is equal to 1. Okay, so now we will check for x is equal to 1. So put x is equal to 1 in un. So you will get un as 1 upon 3n minus 2, 3n minus 1 into 3n. Okay, now to check whether this series un is convergent or not, so we will apply limit comparison test. Okay, so take n common from the denominator. So here we have n cube, right? And this other terms are 3 minus 2 upon n, 3 minus 1 upon n into 3. Now consider vn as what? 1 upon n cube. Okay, so here we have vn is equal to 1 upon n cube. Now we will find limit n tends to infinite un upon vn. So this is equal to limit n tends to infinite 1 upon 3 minus 2 upon n into 3 minus 1 upon n into 3. Okay, now this two term will go to 0. So what remains is 1 upon 27, which is a finite and non-zero term. Okay, now we will see vn. So series vn is equal to series 1 upon n cube is a p series with p is equal to 3. Okay, so we can say that this series vn, that is series 1 upon n cube, is convergent by p series test. Okay, so we can say by limit comparison test that this series un is also convergent for x is equal to 1, right? So at last we can say that the series is convergent for 0 less than x less or equal to 1, and it is divergent for x greater than 1, right? So now let's move to one more example. Is the convergence of a series n plus 1 upon n plus 2 whole raised to n into x raised to n, where x is greater than 0. Here un is given, that is n plus 1 upon n plus 2 whole raised to n into x raised to n. Now here we have un as the form un is equal to vn whole raised to n, right? So we will apply root test. Okay, so for that we have to find this un raised to 1 upon n. Okay, so un raised to 1 upon n is equal to n plus 1 upon n plus 2 into x. Now we will find limit n tends to infinite un raised to 1 upon n. Okay, so take n common from numerator and denominator. So you will get n into 1 plus 1 upon n into 1 plus 2 upon n into x. This n will get cancelled and this two term will goes to 0 as n tends to infinite. So what remains is x. Okay, so by root test we can say that the series is convergent for x less than 1, it is divergent for x greater than 1, and test fails for x is equal to 1. Okay, so now we will check for x is equal to 1. So put x is equal to 1 in un. So you will get un as n plus 1 upon n plus 2 whole raised to n. Now we will find this limit n tends to infinite un. So take n raised to n common from numerator and denominator. So what remains is this. Okay, n raised to n will get cancelled, and we know this limit n tends to infinite 1 plus 1 upon n whole raised to n is equal to e, and from denominator we will get e square. Okay, 1 e will get cancelled, so what remains is 1 upon e, which is not equal to 0. Okay, so by nth term test for divergence we can say that the given series is divergent for x is equal to 1. right? So in general, we can say that the given series is convergent for 0 less than x less than 1 and it is divergent for x greater or equal to 1, right? So in today's session, firstly we study this absolute convergence, right? So here what we have, this series un, we can say that series un is absolutely convergent if series mod un is convergent. Okay, and next we studied this conditional convergence. Okay, so here what we have, this series un, we can say that it is conditionally convergent if this series un is convergent, right? But this series mod un is divergent. Okay, then we can say that it is conditional convergence. Next we studied power series. Okay, so here we have summation n from 0 to infinite an x minus a raised to n. Okay, so we have to check whether this power series is convergent or not. So for that we will apply mainly two tests, that is ratio or root. Okay, so if we have un as the form vn raised to n, then only apply the root test, otherwise we have to apply ratio test. Okay, so I hope you have understood in this session. Thank you for watching.